We're not going to look at the combination, and so we'll go back up here to these knowns. We'll look at this combination. A lot of different things here. So the first thing we're going to do is treat this with chloride to get all the chlorides out. And so this will have all of these chlorides, and we can separate those, warming up the solution to put the lead into solution, and then adding the ammonia to take the silver into solution, and then having the mercury left. So let's look at the rest of these. We want to then get rid of the barium and the strontium. So we're going to acidify it. The barium is the least soluble, so we'll control the sulfate concentration by having the solution acidic. So here's our barium. Now the strontium is a little less soluble. We'll increase the pH so we have the sulfate concentration a little bit higher. We'll spin out, and there's the strontium. So we've got the barium and the strontium. Now we're going to take everything down as hydroxides. This will take everything except for the calcium. So if we do it at pH 10, the calcium hydroxide won't form. If we do strong base, that will form. However, you notice that the chromium forms a complex ion at that. So we could spin that out right now. And here is our chromium. We can then oxidize the chromium, get the characteristic chromate yellow. So let's come back here. This is now at pH 10, pH strong base. We'll take it to pH 10, and you notice now we've got the calcium in solution. We can come back and check that out with the carbonate. So now we have these right here. The cobalt, if we now take it up to a +3, and its hydroxide is very insoluble, so we'll drop the pH, and you notice the cobalt does not go back into solution. So now we have the magnesium and the copper. We take it up to pH 10, we have both of these hydroxides, but copper will form a very nice complex with ammonia. And so you get this beautiful ammonium complex, and the magnesium is right there. So if we do an unknown in that same one, so we do a combination unknown, we'll come in like that. Again, we'll treat it. In this case, this will have all the chlorides. And come back up here. Now let's acidify it and go after the sulfates. There's the barium. And so let's increase it here. No strontium. Now let's come up here, and we do have a precipitate at pH 10. We'll pull that off. We'll now check that to see if we have any calcium. No calcium, and so we'll come back here. So this was at pH 10. Everything's down as a hydroxide. Let's oxidize it. Let's take it up a little bit higher. And we had the oxidizing agent in there. Now we get this characteristic yellow color of chromium. If we take it back down to acidic conditions, we have this light green of the chromium 4. We'll take it back up to pH 10. There's the hydroxide. We go up even higher. There's the chromate color. So it looks like we have chromium.